All right, so in our previous video, we looked at how to do a Lewis dot diagram, and it was quite an easy example because it didn't need any double bonds. Everything just sort of fell into place following these 4 simple steps. This one's a little bit more tricky, not a lot, but a little bit more tricky. Again, it's the sort of thing you would have been exposed to in year 12 chemistry. So the first step is, for my way of doing it, add up the total number of valence electrons. So carbon has got 4, being in group 14. Hydrogen has got 1, but there are 2 of them. So there'll be 2 valence electrons in total from the 2 hydrogens. And oxygen, being in group 16, has got 6. So I add those up and I get 12 valence electrons. So I've done step 1. The next thing is to look at the valency of each of these. Well, carbon has got a valency of 4, each hydrogen has a valency of 1, and oxygen has a valency of 2. This means carbon can make 4 chemical bonds, each hydrogen can make 1 chemical bond, and the oxygen can make 2 chemical bonds. That's what valency means. How many more electrons can it take, or how many bonds can it make? So because carbon has the highest valency of those, I'm going to put that in the middle and have the other things attached to it. So I'm going to do that. I'm then going to use bonding pairs of electrons to add my hydrogens and my oxygen. So I've used up 6 of my 12. I've only got 6 left. I'm going to use lone pairs to satisfy the octet rule for the elements that I need to do that for. Hydrogen doesn't obey the octet rule. It only needs 2 electrons to be stable. It's got those 2 electrons in a bonding pair. So each of these is already satisfying its need to be stable. Oxygen, though, does obey the octet rule. So I'm going to put those extra 6 electrons around oxygen. And that looks pretty good until I check my carbon. It only has 2, 4, 6 electrons here. So what I'm going to do is I'm going to move one of these lone pairs into the chemical bond. So I'm going to move these 2 into here. And it will create another bond. Now, oxygen still has its 8 electrons. 2, 4, 6, 8. So 4 of them from lone pairs and 4 of them from bonding electrons. So it's now satisfying the octet, well, still satisfying the octet rule. Carbon has now got 2, 4, 6, 8 electrons involved in bonding, so it also obeys the octet rule. So if you find, when you put those lone pairs around the outside atoms, that your middle one doesn't obey the octet rule, move a lone pair in to create a double or even a triple bond.